morning. Let's discuss the blast furnace shape. First, why do you think the blast furnace has that typical profile instead of a straight cylinder?
Good morning. The blast furnace shape is carefully designed to facilitate efficient gas-solid interaction, smooth burden descent, and proper liquid collection. It isn't cylindrical because different zones need different cross-sections for reactions, gas flow, and melting behavior.
Interesting. Could you break down the different zones of the furnace and how the shape changes along the height?
Yes, a blast furnace can be divided into 4 zones: throat, narrowest top part for charging and preventing gas escape; stack, sloping section where burden descends and gases rise. Here the shape widens slightly to allow uniform gas distribution. Bosch, widest portion near tuyeres where softening, melting, and reduction occur at very high temperature, 2000 C. The widening avoids choking. Hearth, cylindrical bottom where molten hot metal and slag are collected and tapped.
Why is the Bosch the widest section of the furnace?
In the Bosch region, coke and ore start softening and melting. If the walls were vertical, the burden might stick and block the descent. By providing a widening profile, the furnace ensures smooth burden flow and prevents hanging. It also accommodates the increased gas volume and turbulence caused by high-temperature reactions.
Good point. What about the throat? Why is it made narrow?
The throat is narrow for 2 main reasons: to confine and control the burden charging from the top, to minimize heat loss and prevent the escape of dust-laden gases. Additionally, it ensures better sealing with the charging system.
Can you relate the shape with countercurrent heat exchange?
Certainly. The blast furnace is an excellent countercurrent heat exchanger. Hot gases move upward from tuyeres while the burden descends. The widening stack ensures that ascending gases expand and uniformly contact the burden surface area, improving heat and mass transfer efficiency.
Good. What is the importance of the hearth being cylindrical?
The hearth stores molten hot metal and slag. A cylindrical shape ensures sufficient volume, mechanical strength, and uniform pressure distribution. It also simplifies tapping through the tap hole and allows safe refractory lining.
If the furnace was a simple vertical cylinder, what problems would occur?
Several problems. Burden would not descend smoothly, it may stick and hang. Gas distribution would be uneven, reducing efficiency. No accommodation for burden swelling and softening. Higher risk of channeling, scaffolding, or gas bypass. Inefficient tapping of molten products.
Very well. Can you briefly summarize the engineering logic behind this shape?
Of course, the shape is designed as a narrowing, widening profile, narrow throat controlled charging sealing. Expanding stack better gas, solid contact. Wide Bosch smooth descent, melting, and reaction space. Cylindrical hearth safe storage tapping of liquids. In short, the shape ensures smooth burden movement, efficient countercurrent heat exchange, and safe collection of molten products.
Excellent. One last question. Can you sketch the profile if asked in an exam or interview?
Yes, I'd draw a simplified furnace showing throat, stack, Bosch, and hearth with arrows for gas rising and burden descending. That visually explains why the shape is as it is. Thank you.